Hi all, this is Upasana from Edureka, and in this module we're going to talk all about shell scripting. But before we begin, let me discuss the outline of the topics I'm going to cover for today. So first of all, I'm going to give you guys a little brief on Linux. Why do we need it? What exactly is Linux? A little bit about the kernel and the shell. Then we're going to talk about the command line essentials. As this is a scripting video, most of what you're going to look at is going to be the CLI. Then we're going to start with shell scripting basics, followed by how to use variables, some special variables, and how could you implement them. Then we have basic operators, followed by shell loops and shell functions. And finally, we're going to look at a few use cases in a small scale value to see how shell script is implied in daily lives of people. So without any further ado, let's get started. So first of all, let me introduce you to this thing called Linux. Now, firstly, why do we need Linux? Now, there are a couple of reasons why people into scripting as a background would prefer Linux over any other OS. Firstly, it's an open source operating system, which basically means the source code is available to everybody, which also means that when you use the Linux OS, you can customize it according to the nature of your work. Which brings me to the second point, which is access to the source code. As I had mentioned, the source code is present to everybody. You can make tweaks in the code which suits your needs.
The third point, Linux is highly secure. It is so because it's easy to identify bugs and fix them, whereas when we are talking about a widely distributed OS like Windows, which has a large user base, it becomes a target for developers of viruses and malware. And finally, you shall notice later in this module that if we remove something from the Linux OS, it gets deleted forever, unlike your Windows OS, wherein it gets saved in your recycle bin, cluttering your entire OS and slowing it down, which is why Linux runs faster and is meant for faster systems. Now that we know why do we need Linux, let's look at what is Linux. Now, Linux is a Unix clone which has been written from scratch by Linus Torvalds. It is an open source and community developed operating system for which it is capable of handling activities from multiple users at the same time. Now, we cannot just talk about Linux and not talk about the kernel. Now, the computer programs that allocate the system resources and coordinate all the details of the computer's internals is called the kernel. So basically, the kernel is like the heart of the operating system. It interacts with the hardware, and most of the tasks like memory management, task scheduling, and file management is done by the kernel. Now, users communicate with the OS through a small program called the shell, which we shall be elaborating upon later. Now, this is one of the very interesting applications of kernel, which is the Apple's iOS or the Mac OS. Now, what Apple did as a company was that it put on a pretty skin on your basic Linux kernel to make an OS of its own. Now, Apple uses its own signature operating system XNU since 2001, which a lot of people do not know has been derived from the basic Unix kernel. Back then, it was known as the OS X, which later became the XNU. Now, let's move on to our command line essentials. For that, I'm going to take you to the terminal. Now, because this is a scripting video, we're going to spend a lot of time on the command line interface. Now, this is important because it saves you a ton of time. You can't just keep switching from CLI to GUI in any real-life given scenario. So, I am using CentOS 7, the Fedora version, and I'm running it on a virtual machine. So, first of all, what I'm going to do is I'm going to increase the size of the text a little bit. I think this should be fine. And then let's start with making a list of all the commands that we shall be acquainting ourselves with. For that, I'm going to open the Nano editor and I'm going to name this CLI Essentials. All right. Now, Nano editor is basically a text editor like any other. I could have used Vim instead of it, but I like the Nano editor because it gives you a bunch of options in the bottom and it's just easier to use. So let's start with our list. So we have our basics, which are CD, which means change directory, PWD, which will show you the directory. Then we have ls or list. Then we have the next segment, which is the copy, the move, and the remove. They pretty much do what the name suggests. They copy, move, and remove respectively. Then you have echo, which is like Linux's version of print. You have cat or concatenate. Then you have less, which by definition, both of them should sound pretty similar. But in a bit, I'll tell you why they are different. Then we have grep. We have mkdir, which basically helps you make a directory. And then we have touch, which basically helps you make files pretty quickly. Then we have change mode, which is also pretty significant. I'll tell you in a bit why. And then finally, we have man plus help, which is basically like a manual. Then if I had to save this, I just have to write out. So Control O. Then it'll ask you whether this is the name you want to save this with and hit enter. And then it tells us that we've written 14 lines. Now all I want to do is exit this, so Control X. And here we are back on our basic terminal. So let's start. Change directory. Right now, as you can see, we are at Edureka, our current working directory. So cd/home. It's as simple as that. Now we are at home. Then we can do a cd and back to Edureka. There you go. Then we have pwd, which will show you your current working directory. As you can see, it shows home/Edureka. It's the path of our current working directory. Then we have ls. It shows all these files that are there in our current working directory. Not just that, you can also write ls and specify a path name. So then it'll give you the list of objects that is there in that particular file. So at home, you have these two files called Edureka and Vagrant. Now what else can we do with ls? We can go ahead and look at the flags that are available. For that, all you have to do is --help. Now that works universally through all distributions of Linux. Now this may look like a lot of text now, but if you go up, you will realize that there are flags and their descriptions given on the left and right respectively. You have your -a, which means do not ignore entries starting with your dot. Then you have A, which means almost all, and then it has its description right here. What I'm more interested in comes all the way down here, which is your L flag, or the long listing format. Let's use that and see. Now, I had done ls before. Now, if I go on and do ls-l, it's basically going to show me all my objects the same as ls, but it is going to give me more information about these objects, like the date and time at which this object was created, who is the user group, and on the extreme left, if you see, it basically shows you the permissions, which I'm going to talk a little more about later in this segment. Right now, all I want to tell you is R here stands for read, W for write, and X for execute. So when you see RWX written on the left, it means your user can read, write, and execute that particular file. Okay, with that, let's clear this. All right, let's move on to our next set of command line essential commands. So what else did we have? We had copy. So for copying, all you have to do is type cp, type the name of your file, and then put in a destination path. In this case, I've put in pictures, which is there in the Edureka directory, and with that, it is copied. Now, let's see if it is actually present in pictures. So again, let me just use the list command, and you can see CLI Essentials is right here. Now, let's see how to use the move command. For this, I am going to be moving to this pictures directory. First up, let's just see what other file can we make the move to. All right, we have downloads, we have project, public. All right. So first, let's move into pictures. So now I'm at pictures. What I'm going to do is I'm going to move CLI Essentials to, let's say, I'm going to move it to public. Okay. Now, once the move is done, if we see public, let's list out public. You see there is just one file, which is CLI Essentials. But then if I go back and check pictures, there is no CLI Essentials file, which basically means what moving did was it removed the file from the pictures directory and put it in public. Now let's remove that file from public, with which we can also cover the rm command. So let's move into public. Now as you can see, we are at public. Let me clear this. I'll keep clearing the screen, for which you can just type clear or use Ctrl L. And let me remove CLI Essentials. Now if I do an ls, you see there is nothing there in the public directory. So with that, let me move back to Edureka, the original working directory I was in. Let's see what are the commands that we were using. Okay, we've done cd, pwd, ls, cp, mv, and rm. Next, we have echo. Now, as I had mentioned, echo is like the print command in here. So, if I'm going to say echo, hello world, like we haven't used this phrase a million times already, but I'm going to stick to the cliche and I'm going to still type that. It prints out hello world. Surprise, surprise. And as you might have seen, what I previously did, which was using the cat command, I'm going to do it again. Basically, what the cat command does is it concatenates your text file to this terminal of yours. So what is there in that particular text file, CLI Essentials? I can see it printed right here. Now, how is that different from the less command? Now, if I did the same thing with less, it'll also show you the contents of your text file, but it'll open it on a brand new separate window and just override the previous window you were working on. Now, this is a much neater way, and it helps you from not cluttering the window that you're currently working on. So that was all about cat and less. For grep, let's move back into our original window. For that, all you can do is press Q, and then you're back here. So the next command we're going to do is grep. Basically, what it's going to do is it's going to grab the data from a certain file or a command that you are trying to pursue. So you guys might remember I just used the mv or the move command. So what I'm going to do is mv and go to help, because if you remember, your --help would basically bring out this entire manual of the flags that are there for mv. Then we're going to pipe and we're going to do this thing called grep, and we're going to type out verbose. So basically what I'm trying to find out is the verbose flag available for your move command or not? So as you can see, your -v or the verbose flag, basically what it does is it explains what is being done while you move it. So if you use the -v flag with your move command, it's going to show you basically where you're moving your file. And if suppose you're using a big file, suppose a 12 or 20 GB file, it's going to show you when it starts and when it is finished. With that, let's move on and let's see what else. So we finished cat, less, grep. Next we have touch and mkdir. Now touch will be easy to show. It is basically going to help you create a few files quickly in the current working directory that you're working on. So file1.txt, then we have file2.txt, and let's take file3.txt. Not very original, but just have to show you how it works. And if I do an ls, you can see you have file1.txt, file2.txt, and file3.txt right here. Next, we have mkdir, which basically helps you make a directory in your current working directory. If I just type files, and then I'll do this ls again, you see we have created a directory which it will show you in blue, and we have created files. Then we have chmod or change mode. Now this basically helps you play with or alter the permissions that are associated with a file. Now let me give you an example by running a script. So what I'm going to do is I'll open script. So basically what I'm going to do is that I'm going to write a little script. Now this is in no means me rushing into the next segment. That one is separate. This is just for me so I can demonstrate how you use chmod. So I'm going to go with the shebang line. And I'm going to just go with hello world or hello learner, because we have used hello world a lot. So I'm going to write out of this, Control O, and then we're going to move out of here. Now let me clear this out and let's try to run that particular script. So this is how you run it. You go / and then test.sh. And as you see, it basically shows you permission denied. Now, one thing you should remember is any script that you've just written isn't executable from the get-go. Mostly, you only have permissions to read it. Now, to change that condition, we have something called chmod. So when you go ahead and type chmod and then your +R or +W or +X, it means you're basically adding to whatever permission that there is a permission to execute that particular file. So with that +X, now let's try running this. And as you can see, hello learner. So what I could have done instead of the +X is I could have done this 777 and then test, which would have meant the same thing. But there is a difference from just adding a permission to the user and using the chmod this way. For that, let me open another nano editor called permissions so I can explain it to you further. Now remember how I had said when we were using long lists or the extension -L to ls that on the leftmost column what you could see were the permissions associated with a certain file. Now chmod basically helps you alter that. Now if you might have noticed, the permissions were displayed in the following fashion. Suppose ABC and then ABC and then one more ABC and then the file name and then the date and then whatever. Basically, there are three aspects to it. The first one being the user or you. Second one being the user group. And finally, there's a thing for everybody else. So when you basically type chmod and followed by 3 numbers, you're basically specifying the user, the group and others. And then the file name, which is the basic syntax of chmod. Now, how does this work? Now, these numbers can be anything from 0 to 7, and all those numbers mean something. Now, let's start with 0. We have 0, which is equal to 0, which basically means nobody gets any permission. Then we have 1, which basically means only execute. Then we have 2, which means you can only write. Then you have 3, which is basically the sum of 2 plus 1, which means you can write and execute. Then we have 4, which is read. Then we have 5, which is essentially 4 plus 1, which, as you all might have guessed, means read and execute. Then we have 6, which is read and write. And finally, you have 7, which is 4 plus 2 plus 1, which means all 3 permissions, read, write, and execute. Not going to be saving this. So when you type something such as chmod 777 and a certain file name, your first 7 basically means your user has the permission to read, write, and execute. Your second 7 means your user group also has the permission to read, write, and execute the file. And so does everybody else, which you can see through the third 7. With that, I am closing this. So Control X, and then I'm not saving it. And then finally, I have man plus help, which is basically your general commands manual. You can see the names of all your general commands. You can see your bash bulletin commands. It's basically like your guidebook before scripting. You can press H and it'll open to a summary of commands. And then you can press Q when you are done. Again, Q. Now let me head back to my presentation for a little more on CLI. Now basically, before closing this segment, I'm going to talk a little bit about CLI and how it compares to GUI. So firstly, the first point must be pretty clear. CLI actually stands for Command Line Interface, so it basically means it's a text-based interface. Now the GUI or the Graphical User Interface is a visual-based interface, pretty clearly. It features the use of graphic images, including windows, icons, and menus. Even if it does that, it does require a mouse, which is the most common way to navigate through a GUI. Which brings me to my next point. Icons are easy to use. Because of the visual representation, most people can learn and use GUI much faster and much easier. But once you get used to the command line, I don't personally think it is that tough as well. But for a beginner, yes, GUI can prove to be pretty optimum. But there is also a downside. A GUI's OS is slower because everything you remove does not get permanently removed from the system. It is going to stay there as a copy of the file and going to clutter your space and reduce the speed of your whole system, which is where CLI wins as it has a faster OS. Which also brings me to my final point. Command line interface gives you way more control than your GUI. With a CLI, users have all the control over a file system and their operating systems, and the tasks become really simple. You can create a script that contains a few lines of command and it will do the work for you. Although your graphical user interface can create shortcuts, they do not readily support scripting or automation. So, for common tasks, a user must repeat each action within the GUI manually. Now, nothing is better than the other. It's a personal choice for everybody, but for scripting, obviously, a command line interface is most optimum. It helps you do things at scale. It helps you when you need to script or automate something. You need greater control over systems or functions, and it helps you with less memory usage. With that, let's move on to the shell script basics. So the most logical question, obviously, is what is a shell? As I had mentioned earlier, users communicate with the kernel through a program known as a shell. A shell is basically a command line interpreter, and basically what it does is that it processes your requests. When you type in a command at your terminal, the shell interprets the command and calls the program that you want. The shell uses standard syntax for all commands. So basically what it does is that it translates commands entered by the user and converts them into a language that is understood by the kernel. From the shell, the direct derivative is the shell script. Now the basic concept of the shell script is that there will be a list of commands which are listed in the order of execution. A good shell script will have comments preceded by the hash sign. Now, it is not important for you to have hash signed certain comments for your script to be executed. It is only a good practice to have your steps hashed out so somebody else reading your script can understand what you want to do with it. Now, there are several different types of shells which can be broadly classified into two types. First, you have the classic shell, which is the Bourne shell. A derivative which came later was the C shell. Now, each of these types have their own subtypes. A few examples of the Bourne shell are the basic Bourne shell, the Corn shell, the Born Again shell or the Bash, and the POSIX shell. In C shell, certain examples are your basic C shell, your 10x C shell, and the Z shell, which has been picking up popularity in the past few years. Now, to understand how this works, let me move on to our terminal. Now, what I'll be doing is I'll be dividing the screen into two parts. On my left, I'll have my nano editor, and on my right, I shall be having your basic terminal where you can see your commands being executed. So kindly be patient. Okay, so let's start with some basic shell scripting. Now, shell scripts have several required constructs that tell the shell environment what to do and when to do it. Of course, most shell scripts are more complex than the one I'm going to show you. The shell is, after all, a real programming language complete with variables, control structures, so on and so forth. No matter how complicated a script gets, it still is just a list of commands executed sequentially. So here I'm going to open up my nano editor and I'm going to put up, let's say, example 1 and sh. Now notice the extension sh. This is my extension because I'm using the basic Bourne shell or the shell. So I'll start with the shebang line, and it is nothing but the absolute path to the interpreter of your shell. So it has this hash and this bang or the exclamatory followed by the full path to your interpreter. Now all scripts under Linux execute using the interpreter specified on this first line. So this could be sh or Bourne shell, bash, or your ksh, your zsh, so on and so forth. Now, like we had given the advice of hashing out comments, let me just put on a few comments, make this look good. Okay, and then I'm going to try and print this very simple print, such as what is your name? And then I am going to read whatever you enter, and then I am going to print that out. We're going to allocate whatever we read into this variable called person, and then we are going to call that variable using the $sign. So hello, whatever person. As I had mentioned before, your Control O for write out, and then we're going to exit this. Now this is to remind you one more time that every file which has just been made is not executable. So if I try to execute it now, it would tell me that permission is denied. This is just a recap of what I had done, say 2 minutes ago. So we are going to change the mode, and I'm going to do this when I'm executing any script at all. I'm going to try and execute it now. It's going to ask me, what is your name? Edureka employee, and then it's going to greet me saying, hello Edureka employee. And that is the most basic of the shell scripting that you can do. As we move further, I'm going to keep bringing you back here. I'm a firm believer in practicing what we are learning in theory. With that, let's go on and see what we have next in this module. So the next segment is about using variables. So what is a variable? Most people might be aware of this term, but for those who are not, I'm going to explain it down to the scratch for all of you. Now, variable is nothing more than a pointer to the actual data. It's nothing more, nothing less. The shell enables you to create, assign, and delete variables. So basically what it is that a variable is a character string to which we assign a value. The value assigned could be a number, text, file name, device, or any other type of data. The shell enables you to create, assign, and delete variables which may contain numbers, texts, file names, devices, or any other kind of data. Now, variables are of 3 kinds in the shell. You have your local variables, which, as the name suggests, is the variable that is present within the current instance of the shell. It is not available to programs that are started by the shell, and they are set at the command prompt. Then you have your environmental variable. An environmental variable is available to any child process of the shell. Now, some programs need the environmental variables in order to function correctly. Usually, a shell script defines only those environmental variables that are needed by the programs that it runs. And finally, we have the shell variables, which can be compared to the global variable if you're into any other kind of programming. A shell variable is a special variable that is set by the shell and is required by the shell in order to function correctly. Now, some of these variables are environment variables while others are local variables. It can be any of these. Now, to see how we can implement these variables, we are going to move on to the shell. But before that, let's see specifically what we are going to look at. So first of all, we are going to learn how to define variables, how to access the values. Then we're going to see a little bit on read-only variables and unsetting variables. Then we have special variables. We're going to see how you can work with them. We have command line arguments. We have special parameters and the exit status. Now, to see how all of these things work, let's move on to our terminal. So again, I'm going to create another nano file called variable.sh. Now, defining variables. Now, any variable that you are going to define should be along the lines of this. You have your variable name, and then you have your equal sign and your variable value. Now, if you have done any sort of coding or programming before, you would know this is basically how you allot a value to a variable throughout all different platforms. Now, the thing you have to notice is that in shell scripting, it's very particular about the syntax. So no spaces on either side of your equal to sign. In that case, it is not going to execute and it's going to throw an error at you. So let's take something simple. So your name equals this. Now this example defines the variable name and assigns the value Edureka employed to it. Variables of this type are called scalar variables. Now a scalar variable basically means that it can only hold one value at a time. So let's turn this into a shell script first. So I'm going to go up and put in my shebang line. And then I have my name, and then we're just going to call that particular variable. Pretty simple, and we've done it before. So then Control O here. Again, we have to give it permissions. And then when we execute it, it prints out what we had asked for it to print out. Okay, let's see what happens when I use the read-only command. And then I try to change the value of the variable. Suppose I put in my own name into it. I'm going to go Control O and OK. Basically, it's going to throw an error at me saying that the variable name is a read-only variable. So I cannot change the value of the variable once I put read-only in front of it. Now that was all about read-only variables. Now let's move on to see what else can we do with this. Now there is also something called unsetting variables. Now unsetting or deleting a variable directs the shell to remove the variable from the list of variables that it tracks. You'll see in a moment what I mean. So I did this, and then instead of read only, I'm going to put unset. And then I'm going to call my variable same old, same old. And now we are going to try and call this. As you can see, nothing. So basically what it did was it took the variable out of the list of other variables. That is what unset does. Now let's clean this out and we can look at special variables. Okay, so now let's discuss a little bit about special variables. So in the previous segment, you understood how to define a variable, how to read only and unset a variable. Now these variables are reserved for specific functions and hence they are called special variables. Now they're usually preceded by a $sign, and these are the special variables that we are going to see. You have your $0, which is the file name of the script. Then you have your $any number 1 to 9. Now these variables correspond to the arguments with which a script was invoked. Here you can pick any n number, which will be a positive decimal number corresponding to the position of the argument. You shall understand when I demonstrate this further in this segment. Then you have your $sign. Now this will basically return the number of arguments applied to a script. Then you have your $ and asterisk. So this will return you all the arguments that are double quoted, which again you shall see when I demonstrate this. Now this will give you all the arguments that are individually double quoted. That is the only difference between the $asterisk and the $sign. Then you have this, which is the exit status of the last command that you have executed. And finally, you have the $, which will give you the process number of the current shell for the shell script. Now this is also the process ID under which it is being executed. Now let me try to script something with which I can depict not all but at least most of these special variables. So let's just put on echo, take $0. Let me go ahead, select it, and then copy it a bunch of times. Okay, so let's go ahead and execute this. So now that we have learnt about all of these special variables, let's implement them using command line arguments. Now, command line arguments, as you can see on your left, are these $1, 2, 3 to 9. They are actually positional parameters with $0 pointing to the actual command, following which your $1 and your $2 are the arguments to that particular command. If you see the script on your left, this is how it will run. So first we are going to change the mode. Then we are going to run it and pass a parameter here. So if I pass Edureka employee, or I've typed that too many times, so Edureka learner, and enter, it shows you the file name, $0, your parameter number 1, which is Edureka, your second parameter, the quoted values, and the number of parameters, all of which are returned to us by our special variables. Now, as you might have noticed, your $@ and your $sign returned pretty much the same thing. These are the special parameters that allow accessing all the command line arguments at once, which in our case is Edureka learner, both of these arguments. So both of them actually act pretty much the same unless they are enclosed in double quotes. Now let me show you how. If I run the same thing, but I put them in double quotes, you can see both of them again give the same value. But if I put them in individual quotes, it will treat them as two separate parameters and will give you two separate values. Whereas in the first one, it will quote your number of parameters as one. It will consider it one single string. Now let me try and demonstrate it using another shell script. How is it different? This does not make a lot of sense to most of you right now. So let's just hope the next thing makes it better. So I'll run a little for loop here, which again we are going to touch up on later. But for now, let me just do this to demonstrate how this works. Now let me put this in perspective. So what I'm going to do is I'm going to run this entire sentence, Edureka wishes you happy learning. And you see what just happened, right? What your special parameter did here is that it took this entire list and separated it into separate arguments. And that is what these two special parameters do. Now once you're done with it, you can always use the exit status. So what I'm going to do now finally is I am going to go and implement the exit status, and it is going to return a value of 0. Now this is basically the exit status of the previous command. It would have given you a 1 if your previous command was unsuccessful. Since your command was successful, it gave you a 0. So the exit status is basically a numerical value returned by every command upon its completion. As a rule, most commands return an exit status of 0 if successful and 1 if unsuccessful. Now some commands also return additional exit statuses for particular reasons. For example, a few commands will differentiate between kinds of errors and will return various exit statuses depending on the specific type of failure. With that, we've come to the end of this segment. Let me go back to my presentation. Next, let's take a look at our basic operators. Now, there are various operators supported by each shell. I'm not going to take a lot of time with this segment. We will discuss about the default shell in this segment, and we are going to discuss the following operators. We have the arithmetic operators, relational operators, Boolean, string, and file test operators. So this is the first table, and these are your arithmetic operators. You have addition, subtraction, multiplication, division, modulus, assignment, equality, and not equality. It's very important to understand that all these conditional expressions should be inside of square braces with spaces around them. Now all the arithmetic calculations are done using long integers. Next we have relational operators. Now the Bourne shell supports these relational operators that are specific to the numeric values. Now these operators do not work for string values unless their value is numeric. We have again the equal operand, not equal to, greater than, less than, greater than equal to, or less than equal to. Then we have the Boolean operators, which are just three. There is the logical negotiation, logical or, and logical and. And finally, we have the string operators, which are equals, not equals, check if operand is 0, not 0, and check if string is empty. And finally, we have the file test operators. Now we have a few operators that can be used to test various properties associated to a Unix file. Now assume a variable file holds an existing name of the size 100 bytes and has to read, write, and execute permission on. So you have your -b, which checks if the file is a block special file. Then you have -c, which checks if a file is a character special file, if the file is a directory, which is -d. -f is if a file is an ordinary file as opposed to a directory or a special file. Then you have -g, which checks if the file has its set group ID. -k, which has its sticky bit set. -p, which is a named pipe. -t, which checks if it's associated with the terminal. -u has its set user ID. R is readable, W is writable, and X is executable, which we had discussed before. Then you have S with a size greater than 0, and E if the file exists. Now these are specific to the Bourne shell. There are other operators that are available in the C shell types, but you shall find a lot of content surrounding that. It's not really crucial to discuss that in this module, so let's move on. Next, we have shell loops. In this segment, we are going to discuss shell loops in Linux. A loop is basically a very powerful programming tool that enables you to execute a set of commands repeatedly. Here we shall discuss the while loop, the for loop, until loop, the nested loops, and loop control, which will include the infinite loop and how to get out of it with break and continue commands. For that again, as most of you might have correctly guessed, let me head back to the terminal. So first let's discuss the for loop. So the for loop operates on lists of items. It repeats a set of commands for every item in the list. So let me open the nano editor. Let's call it edit. Alright, so basically this is how the syntax of your for loop goes. For your certain variable in, say, your word 1, word 2, so on and so forth till your word n. Then you have a do statement, whatever you want your for loop to do, and then done. And this is basically how your for loop works. So here I'll give you a simple example of how the for loop works. It's basically going to span through a given set of numbers set 0 to 9, and upon execution it should print all those numbers. It's basically printing out this variable for all the variables that are there in the set. It's pretty simple. So again, chmod and there we go. Now what if you had to do the same thing using another way? We have for you the while loop. Let's get out of here. Let's open this and see how the while loop is different from the for loop. Now the while loop, what it does is that it enables you to execute a set of commands repeatedly until some condition occurs. So it is usually used when you need to manipulate the value of a variable repeatedly. The syntax of a while command looks something like this. So you have a while and then you have a command, a condition if you will. Then you do, and then there's this statement, what you want to be done, and then done. I'm going to demonstrate the same example using the while loop. Now this is basically going to do what we did with the for loop, but using the while loop. We start with assigning a value to a, which is our variable. Now we say while a is less than 10, it's going to print a and then increase the value of a to a plus 1. That's all that is there inside the loop. Now let's try executing this. Again, I'm going to change the permissions. And it prints the same exact thing. Here the shell command is evaluated if the resulting value is true. So, as long as a is less than 10, it will keep printing a and adding 1 to it. Once it reaches 10, your while loop breaks and you come out of the loop. Each time the loop executes, the variable a is checked. Let's try doing this one more time using the until loop. Let me clear this out. Now, the while loop is perfect for a situation where you need to execute a set of commands while some condition is true. Sometimes you need to execute a set of commands until a condition is true. And that is where you use the until command. I'm going to go back here, and you'll notice that the structure of until command is pretty similar to that of your while. Again, you have your until statement, then the command or the condition, then you have your loop beginning, whatever you want to happen in the loop, and then done. Here, once the shell command is evaluated, if the resulting value is false, the given statement is then executed. If the command is true, then no statement will be executed and the program jumps to the next line after the done statement. So again, because I'm lazy, I am going to do the exact same thing as I did twice before, but this time using the until command. Same thing. Here instead of while, it's until. So until your A is not less than 0, it's going to keep printing A and then incrementing the value of A. So even if what gets printed is the same, you know for a fact that how the procedure was gone about was different. When you use the while command, your statement is executed while your condition is true. But when you use the until command, your statement keeps executing until your condition is true. With that, let me clean this out and then we shall move to nested loops. Let me get out of here. Okay. Now next, let's talk a little bit about the nesting of loops. Now all the loops support nesting concept in Linux, which means you can basically put one loop inside another similar or different loop. This nesting can go on up to unlimited number of times based on what you require. Now let me give you an example of nesting using the while loop. So remember the simple while loop that you ran, which went from 0 to 9? What we're going to do is basically we're just going to add another while inside the previous one. So nano. Okay. Remember till here, it's pretty much the same as the previous one. That is your first loop. Inside, we are going to assign the value of A to B. And while your B remains greater than 0, it's now going to go to a new line, which is this N flag, print B, and then increment B. Once it comes out of the loop, it's going to increment A, and so on and so forth. Let me show you what this looks like. Now the result here is not very important, but what you need to understand is how the basic structure of the loop is and how it works. So again, like you can see, A starts with 0. Now, while A is less than 10, 0 being less than 10, A is assigned to B. Now, while B is greater than equal to 0, which now B is, it is 0, it's going to go to a new line and print B. It printed 0. Then, it's going to increment the value of B and turn it into 1. And now, once B is incremented, it gets out of that loop, followed by the increment of A, which now A becomes A plus 1, that is 1. And it keeps going on and on and on and on till finally your A is no longer less than 10. So with that, let's move on to our next topic, which is of loop control. Here we are going to discuss some very important concepts. But before I introduce the concept of loop control, first we need to understand what infinite loop is. So let me create an infinite loop. So let's start with A equals, suppose 10. And let's go saying as long as A is greater than 0, start your loop. And you're going to print A. And then we are going to increment the value of A. And then done. Control O. And now what this is going to do is it's just going to go on and on and on and on and on because it will go on until a is greater than 0 and it's always going to be greater than 0. So let me just put a stop to it. This, by using Control C, I can put a force stop to it. Now you can also do that using something known as the break statement. Now the break statement is used to terminate the execution of an entire loop after completing the execution of all the lines of code up to the break statement. Now let's see how that works. So I am going to exit this, and now this is a simple example which shows that the loop will terminate as soon as a becomes equal to 5. So let's go ahead and you go and 1, 2, 3, 4, 5. Now another statement associated to it is the continue statement, which is similar to the break statement, except that it causes the current iteration of the loop to exit rather than the entire loop. So this statement is useful when an error has occurred, but you want to try to execute the next iteration of the loop. Let's look at one of those. So basically what you see in this script is that this loop makes use of the continue statement to return from this particular statement to the next one, which is the found odd number statement. So if we try to run it, you will receive this result. Found an odd number, even, odd, even, odd, even, odd. It's basically very similar to the break command, except for the fact that your break command will exit the entire loop, while the continue statement will only exit the current iteration. On your left, you see this little script where we are trying to see these numbers that we have put in 1 to 7, which of them are even and which of them are odd. Now what you'll see here is that the script uses the continue command to exit from this particular statement to this particular statement. So if I tried to run this, it keeps exiting this to produce this even number statement. With that, we come to the end of shell loops. Let's go back to the presentation to see what we have next. So in this segment, we will discuss in detail about functions in the shell. Now basically what functions enable you to do is to break down the overall functionality of a script into smaller, more logical subsections, which can be then called upon to perform their individual tasks whenever needed. So in this segment, we are going to talk about creating functions, passing parameters, returning values, nested functions, and calling from prompt. So here we are at our terminal. Let's again open our nano editor. So to declare a function is very simple. What you will have to do is type your function name and then go ahead with your list of commands and then close the bracket. This is all that you have to do. Now let's start with this very basic function. Start with the shebang again, not to be confused with the shebang in the pop culture that we use. So what we're going to do first is that we're going to define function. So again, this is my function name. It's going to be hello. And then I am going to just print hello learner. Nothing very complicated. And then all I have to do is just invoke my function or call my function, whatever it is. So hello, then I'm going to save it. And here, it basically called that function. And that's how simple that is. Now, using functions to perform repetitive tasks is an excellent way to create code reuse. This is an important part of modern object-oriented programming principles. Now, shell functions are similar to subroutines, procedures, and functions that are present in your other software and hardware coding languages. The idea here is to break down a big program into smaller, more logical subsections, which can then be called whenever they needed. Now, You can define a function that will accept parameters while calling the function. Now these parameters can be represented by $1 and $2 as we had passed parameters early on, if you remember. Now here, if I make some minor changes to my function, I think I can make it accept parameters. So hello, and I can put two different parameters. And then what I can do is I can put those parameters right here. Let's say I'll put two names. Let's say I'll put Priyanka Chopra because, pretty international. Let's just keep it that way. And that is what it called. Basically, these two parameters were captured and printed in this function. What you can also do is return values from functions. If you execute the exit command from inside a function, its effect is not only to terminate execution of the function, but also the shell program that called the function. If you instead want to just terminate the execution of the function, there is a way to come out of the defined function. Now, based on the situation, you can return any value of the function using the return command. So, again, what we can do is make some changes here. Let me return this. Another thing I'm going to do is capture this 10 value that has been returned from my previous command. Alright, so what I'm going to do is I'm going to print this out by echo, and then return value is, so I'm going to put this here. So here, as you can see, the parameters that we had passed and the value that has been returned. Now, one of the more interesting features of functions is that they can call themselves and also other functions. A function that calls itself is known as the recursive function, as most of you might know. Now, I'll also give you an example demonstrating the nesting of two functions. So let me just clear this out. I could open a new nano editor, but let's just say I am very lazy. So okay, now let's execute this. Basically, we have a function number 2 inside the function. Number 1 function is saying alpha online over and then calling number 2. And number 2 here is printing beta online. And then we are calling the function number 1, which is our superset, if you may, in the function. So if we execute this, we get the first one, alpha online over and beta online. I clearly watch a lot of movies as well. And now you can put on definitions for more commonly used functions inside your profile, and these functions will be available whenever you log in, and you can use them at the command prompt. Alternatively, you can also group the definitions in a file and then execute the file in the current shell. With that, I come to the end of the segment as well. Now we are going to move on to some used cases on a small scale, of course, to see how shell scripting is used on a broader scale on a day-to-day basis. So I am going to clear this, and I am going to clear this as well.
So let's run a few simple scripts to scan and monitor network using the combination of your shell script and your ping command. Obviously, these scripts are no match to a full monitoring dedicated software like Nagios, but they could be useful for small home brand networks where implementing sophisticated monitoring systems can become an overhead. Let's look at something simple first, okay? Let's look at a scan. So your dot slash. Okay, so let me just show you the code for this. So right now we are going to run a few simple scripts to scan and monitor the network using a combination of bash and ping. Now, this is a disclaimer here. These scripts are no match for a full monitoring dedicated software, something like your Nagios, but they could be very useful for small home brand networks where implementing sophisticated monitoring systems can become an overhead. So let's start with something simple like scanning a network. So this is the code. In this script, what we are going to do is we are going to scan the network for hosts that are attached to an IP address, and the script will print the message nodes with IP. So if your IP address is up, then your ping command was successful. Feel free to modify the script to scan your host's range whenever you try it. So as you can see, it starts with your basic shebang line. Then we are using our ping, and we are basically checking for the exit status for being 0. Now, if your exit status is equal to 0, then it will print that your IP address is up. Pretty simple. If we go deeper into it, now we're going to run this loop for IP addresses from 1 to 255 in the subnet 192.168.2. Basically, what's going to do is it's going to ping these many systems and check if they are up and then disown them. All right, let's try running the script. Now, as you can see, these many systems are up in this particular subnet. We have a bunch of different ones. One of them should be mine. This one seems like it's mine, and so on and so forth. All right, let's move on to our next script. Basically, what I did just now is I force-stopped this script. All right. Okay, now what we're going to do is we will try to send an email to my email address when the ping cannot reach its destination, which probably means the host is down. So system admins can execute this in a script regularly with the use of a cron scheduler. Now this script uses ping command to ping the host or IP that is supplied to an argument. And in case that destination is unreachable, a mail command will be used to notify the system administration about this event. So let's look at this. So cat. All right. Now this is what the script looks like. Also a pretty small code. Again, it starts with the shebang line and it runs a for loop. Now here you can see there is a special variable used, which is your $at, which basically means that all the arguments are individually double quoted. So inside this for loop, basically we are trying to ping all the parameters that are passed, and if the set parameter is not equal to 0, then we are going to get a mail to this particular email address that the host is down. All right. So previously we had checked for an entire subnet. That is why we didn't have to pass on any arguments. But here, since we are not running it for an entire subnet, we are going to try it on some trusty websites. So before I call in this code, I would like to show you that this is what my Gmail tab looks like. There's nothing in my inbox currently. So what I'm expecting is that when I pass on an argument which is not supposed to be up, I'm supposed to be getting a mail in my Gmail, right? So let's run this. Let's put in google.com because we know it's always running. Let's put yahoo.com. Let's put in an imaginary IP, which I'm sure. Let's hope this does not exist. Let's put on one more for safety. Okay, now we've put in for, we know for a fact that google.com is always up, so is yahoo.com. Now we'll have to check which of these two IP addresses is not up. Now let me open my Gmail and check. And as you can see, I have two new messages, and if you open the mail, you can see the message that we had put in as input. All right. Now that we've done these two things, let us try an extended version of the same thing. Now I force-stopped this particular script from running because it will go on and on and on and on. Now what we're going to do is that we're going to create a monitoring log. So the last example I'm going to show you here is a modified version of the previous two examples. Now this example that I'm going to show you is a modified version of what I just showed you. When the mail is not configured on the system, the script will create a log file. Now, the core of the script is wrapped into this endless while loop, which is set to execute ping and check every minute. Feel free to modify the script according to your own needs, and you can also go ahead and remove the endless while loop when you intend to use the script with a cron scheduler. Alright, so let's see what our script looks like. So this is our script. Let me break it down for you a little bit. So first of all, I've created this log file which is going to save if your host is up or down in a temporary log file. It basically is a directory. Then I have created another variable called seconds. So this script is going to run every 60 seconds to check which host is up. The email is my email, which I had shown you previously. Then the for loop begins. Now this is very similar to the previous code that we had just run. This is the same part, and here we have an infinite loop, which is basically what we're going to run to check if a host is up. So we're going to ping the various arguments that we're going to pass, and if the said argument is not equal to 0, then the status gets logged into our monitor log. And if the status is down, then again, like our previous code, we get a mail that our host is down. Else, if the host is up, you just ping OK, the host is up, and there is no mail. Now the reason why I'm not sending a mail when the host is up, if suppose somebody uses this code to check a subnet of a lot of systems, you do not want to spam yourself with a bunch of different mails saying the host is up. That is not important. We want to know when a host is down. And then this if condition closes with an fi, and your argument being up is also sent to the log. And then we have sleep for the seconds variable, which we have put up as 60 seconds. So as I had mentioned, the script is going to run every 60 seconds. So let's run this. I'm going to check for google.com and this imaginary IP address, which as we had previously seen is not up. And then let's put in yahoo.com and yahoo123.com, which I'm hoping is not an actual website. Let's put in this 2.2.2. Now let's run the script. This might take some time, so kindly be patient. Let the script run. So while it runs, let me explain this to you. As you can see, the core of the script is wrapped into an endless loop, which is set to execute ping check every 60 seconds. Whenever you try the script, feel free to modify it according to your needs. And if you intend to use the script with a cron scheduler, feel free to remove this endless loop, because that's what a cron scheduler will do on its own. Okay, so I think that's enough time. Let me just stop this. And as you can see, I've already gotten the new messages here. Again, as you can see, this does not exist, this does not exist. The hosts are down, so our ping has failed. And so we've gotten these mails. Now, what else can we do with it? Let's try to understand a script to create a network backup sort of a file. So let's see what that code looks like. So for this code, I'll have to go back to root. Let's check if our file is here, and it is. So let me show you the code for creating a backup of a file in your network to your local system. All right. Now this is what your code should look like. So first of all, you're going to mount the shared directory, which basically means you're not creating a copy of the directory, but if you make any changes in your local file, it will be reflected in your shared file and vice versa. So CIFS is basically used for sharing your window file. This is the path of your shared file, and this is the path to the local directory where you're going to create your backup. We've had a username Edureka, and we've set the password Edureka. That is what -o does. So again, we've mentioned what are we going to back up. This is the file that we're going to back up, and this is our destination. Now basically, we're going to create a backup and save it in the name of the day. So for example, today is Thursday. So if I create this backup today, then it's going to be saved in a folder called Thursday. Our host name is localhost, and so our archive file is going to be localhost hyphen the name of the day, which is Thursday. .tgz is basically your tarball file extension, and then we've put in a print of the start status message, which is basically supposed to inform us that we have started creating the backup. What CZF does here is it basically creates a zip file, because we're obviously going to import files into the local system, and in the end it is going to show us a message called backup finished. And finally, we are going to unmount our shared directory. So first, let me show you the file that I am trying to back up over here. So now that we know what the code looks like, let's give it a run. So /. So as of now, it's creating a backup, and remember I had told you this is how it's going to name it: localhost _ Thursday.tgz. Localhost being our host name and Thursday being today's day. And it's also showing us that these are the folders that are present in our backup directory. So how are we going to see it? Let's first head on home, change directory to Edureka. So let me clear the screen and let me head on home. So here I'm home at Edureka, and this is the list of everything that is there. So as you can see, there is a file created here called backup, and now we're going to extract the files and see if the code that we've run has actually worked or not. So let me go to that file, and so now I'm going to unzip the file and see if actually. Now let's go in here and check if we actually have our files in or not. Let's go and unzip this file. And here are all the files that are present in that particular folder. We have a bunch of PNG images, as you can see. Now, if the same thing I had to show you in GUI, so I'll go to home, and this is my backup file. This is and these are the PNG images that have been imported into this folder. With that, I come to the end of my demo. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!